Alright, so I hope you understand now what is IPSec side-to-side VPN. At least high level overview of VPN you understand, right? So IPSec is a method of connecting multiple geographically distributed networks securely, right, over the internet, public network, right? And for security there is data encryption, converting plain text to ciphertext, right? Different algorithms are there like AES 256, DES or triple DES. Data integrity check, MD5, SHA-1, SHA-256. For anti-replay, sequence number is used like for this anti-replay, and sequence number is one of the important attribute of ESP header. And the fourth one is data origin authentication. Alright, so for complete security, data encryption, data integrity check, anti-replay and data origin authentication. It establishes a secure communication tunnel between two or more sites, allowing data to be transmitted securely between them. This type of VPN is commonly used to connect branch offices, remote offices or partner networks securely, because side-to-side VPN is different than the remote access VPN. Because in remote access VPN we do have choice like either SSL or IPSec, client based or clientless, whereas in IPSec side-to-side VPN we do not have choice. No VPN client software is required, so each site should have VPN gateway, right? So we will understand remote access VPN later on. So first let's finish side-to-side VPN, of course understanding theory, and then we'll jump to the lab part of it like implementation, how we can configure IPSec side-to-side VPN in FortiGate. And once we have done with IPSec side-to-side VPN, then we will go to remote access VPN section. So if you look at the diagram, then I hope you understand now, like internal network address 10.0.0/8, there is another network or maybe branch network 172.16.0.0/16. Objective is to ensure secure connectivity between both like networks, HQ and branch network, right, using internet as the transport. So transport here is internet. So on top of that we set up or we build IPSec tunnel between both like headquarter VPN gateway and branch VPN gateway, right? So this way private network is extended. Okay, means users from headquarter site can now communicate with branch network using private IPs, because NAT is not required, public IP is not required. Reason, FortiGate firewall like adds extra header to the original packet, and extra header means new IP header and of course ESP header. A new IP header means source IP address, VPN gateway, WAN interface IP. Destination IP means tunnel termination point, remote VPN gateway IP address, right? So as long like packet is routed through internet cloud, so external IP header will be looked at, and source and destination both public IPs, right? So once a packet reaches to the destination or like tunnel termination point, extra headers or outermost headers are removed, like no like IP header, no ESP header, and original packet is extracted then. All right, after decryption, like original IP, sender and receiver IP address will be now known and internal routing will be done. And that's the reason like whenever we set IPSec side-to-side VPN tunnel, then we turn off, we disable NAT, because NAT is not required. Okay, so up to this point, of course, original source, original destination address, original packet. But once packet is put inside the tunnel, then like internal or original IPs are hidden now, right? New IP header is added, and new IP header means source IP, sender VPN gateway IP, maybe 1.1.1, here 2.2.2, right? Both public IPs, routing wise no problem whatsoever. Internet router, yes, they definitely would have route for public IPs, and that's the reason NAT is not required here, right? Makes sense. So IPSec, as I mentioned before, is an ITF standard framework, Internet Engineering Task Force, ITF standard framework that help us to protect IP traffic on the network layer. And why? Because IP protocol itself doesn't have any security features, you understand, right? So for that, IPSec is used. IPSec can protect our traffic with the following features: data encryption, and for data encryption, like AES 128 advanced encryption standard 128, or AES 256, like 256 bits, and there are other like encryption method also, like legacy methods like digital encryption standard, triple DES. They like very weak encryption, so not recommended to be used in IPSec. So nowadays we prefer to go with AES 256 encryption algorithm to make data confidential. And for the data integrity, legacy algorithms like MD5, message digest 5, secure hash algorithm 1. Now like we prefer to use SHA-256 for data integrity check, right? Data integrity ensure that data is not tampered during transit. Okay. NT-replay, again, like when original packet is further encapsulated, extra headers are added. So one of the header here would be ESP header, right? ESP encapsulating security payload, and ESP like provides data encryption, data like authentication, integrity, everything. So ESP has one of the important attribute as SPI, security parameter index, 32 bits hexadecimal, and another is like sequence number, right? So sequence number is mainly used for this purpose, NT-replay pack purpose, right? So whenever VPN gateway receives encrypted packet with the like sequence number already that has been like used or received packet with the same sequence number, so VPN gateway immediately discard that packet. All right. So sequence number plays important role here. And then the fourth one is data origin authentication. So all part of IPSec framework. IKE is another important protocol, because if there are two VPN gateways, gateway 1 and gateway 2, so what happens, like between both VPN gateways, two tunnels are created. And let me explain that. So VPN gateway 1 and VPN gateway 2 means firewall, of course, here FortiGate firewall. Okay, internet is the transport. So basically two tunnels are created between both the gateways, like the first tunnel, also known as IKE phase 1 tunnel. Phase 1 tunnel is basically a bidirectional tunnel. Bidirectional tunnel means only one tunnel between both gateways. Data is sent and received using the same tunnel. But first tunnel or phase 1 tunnel is not basically data plane tunnel. It's not meant to be used for user traffic. So not for user traffic. So phase 1 tunnel or first tunnel is used by both the gateways to exchange data, some information. I mean, like required to build the phase 2 tunnel, but phase 1 tunnel is not data plane tunnel. So you can understand like it's a management or control plane tunnel. Phase 2 tunnel is basically data plane tunnel, and phase 2 tunnel is unidirectional, means a pair of tunnels are created, minimum a pair, one like inbound and another outbound. and inbound for gateway 1, then of course outbound for gateway 2, outbound for gateway 1, then inbound for gateway 2, right? Means like two different SPIs or security parameter index, some value in hexadecimal. So IKE phase 2 tunnel is basically unidirectional, and phase 2 tunnel is data plane tunnel. So user traffic is transported or sent using data plane tunnel, not the phase 1 tunnel, right? So for security association to build a phase 1 and phase 2 tunnel, there is only one protocol here, and that is IKE Internet Key Exchange, UDP port number 500. So IKE is used to build both tunnels, phase 1 tunnel and phase 2 tunnel, and also there is another important protocol here like IPSec protocol and negotiated during phase 2 tunnel, and is ESP basically. We do have like another option here like that is AH, but AH is never used in IPSec tunnel because AH doesn't provide encryption. So AH is like I've seen like used in IP version 6 protocol authentication, maybe somewhere else, but generally in IPSec side-to-side VPN, AH is not used, right? ESP protocol is used. So basically IKE is the protocol, main protocol like that is used to build both the tunnels. Alright, so IKE Internet Key Exchange, UDP port number 500. Its primary function is to negotiate the parameters and establish the cryptographic keys required for secure communication, right? Because what happens like during phase 1 and phase 2 both tunnel negotiation, security attributes are negotiated between both gateways, between both VPN peers, and security attributes means like encryption method, hashing method, or data integrity method. There is another attribute DH or Diffie-Hellman group, key lifetime, authentication method, right? So these security attributes are negotiated during phase 1, and once like phase 1 tunnel is successfully built, then again another negotiation starts, phase 2 tunnel, that is data plane tunnel. And in phase 2 tunnel VPN peers authentication is not done, but otherwise encryption method, hashing method, and even if required then DH group, like if PFS is enabled, perfect forward secrecy, then DH group is again negotiated, lifetime is negotiated, right? So IKE job is like to negotiate security attributes, security parameters, and also cryptographic keys required for secure communication. So there are two phases to build an IPSec tunnel, as I said before, like phase 1 and phase 2, but phase 1 is not data plane tunnel, not for the user traffic, right? But it is bidirectional, only one tunnel, not a pair of tunnel, right? So the main purpose of IKE phase 1 is to establish secure tunnel that is used for IKE phase 2. And in phase 1 again there are two different modes, main mode and aggressive mode. So generally we prefer main mode because total 6 messages are exchanged between both the gateways, right? First two messages like security association, security attributes means proposal and agreement. So gateway 1 sends proposal message and gateway 2 responds with agreement. So proposal and agreement means like again the same, like as I said before, encryption method, hashing method, DH group, lifetime, authentication method. And then after DH key computation is done and DH keys are exchanged in packet number 4 and 5, 3 and 4, and then 5 and 6 is about VPN peers authentication. So in main mode total 6 messages are exchanged between both VPN peers, whereas in aggressive mode only 3 messages are exchanged, right? Main and aggressive mode. Nowadays we even use IKE version 2, means version 2 of the IKE protocol, and in IKE version 2 as there is no main and aggressive mode. So main and aggressive mode means IKE version 1.0, right? IKE version 1.0. Phase 2 is also known as quick mode because it's very quick in fact, and phase 2 tunnel, as I said, like is data plane tunnel, user traffic for user traffic, and is unidirectional. So pair of tunnels are negotiated or created between both VPN gateways, right? One for outbound, another for inbound. And how, like, identified with the SPI, security parameter index. There are two important fields or attributes of ESP header. So whenever encapsulation and encryption is done, right, this portion, so basically ESP header encapsulating security payload, and ESP uses protocol number 50. So there are two important headers or attributes of ESP header. One is security parameter index, value in hexadecimal, and another one is sequence number, again 32-bit sequence number, 32-bit SPI number. Sequence number is mainly used for anti-replay or anti-replay detection, and SPI is like security parameter index, is a unique identifier value, and basically like whole bunch of like encryption, authentication, and other methods are not sent with each packet. SPI number is encoded here, and with SPI number even the receiving VPN gateway understand how I should decrypt the packet, what are other methods, because information is stored in security association database or SAD, right? It's like something security policy database. No need to get into those details, right? But yes, like SAD and SPI really very important here in IPSec side-to-side VPN. And another important point I must mention here, whenever we configure IPSec side-to-side VPN between sites, right? So there are two different ways to configure side-to-side VPN. One is known as policy-based VPN, or domain-based VPN, and another one is route-based VPN. Nowadays, like, we always prefer to go with this route-based VPN configuration, because in route-based VPN, what happens, routing, whenever gateway receives any packet coming from the LAN side, so it immediately checks the routing table whether I'll have to put that traffic inside the tunnel or means encrypted traffic, or just I'll have to send that traffic natively to the physical interface, not putting that traffic inside the tunnel, right? So whether traffic or data will be encrypted or not is determined on the basis of routing table lookup. Routing table or route lookup plays important role here, right? So this type of configuration is route-based VPN. So in route-based VPN, we do routing. In fact, we create route, like in order to reach a remote network, exit interface should be tunnel interface, and tunnel is further protected with IPSec, right? And another important point to understand here is, in route-based VPN, even if there are multiple networks or subnets behind each gateway, still only one pair of phase 2 tunnels are created. Only one pair of phase 2 tunnels, no matter how many networks or subnets we want to protect with IPSec, right? Whereas in policy-based VPN, phase 1 tunnel is still only one phase 1 tunnel, right? But what about the phase 2 tunnel? In policy-based VPN, number of phase 2 tunnels is determined on the basis of networks or subnets that need to be protected. For example, if there are two subnets or two networks behind gateway 1 and two networks or subnets behind gateway 2, they all need to be protected with IPSec tunnel. So what happens here, total 4 pair of tunnels, phase 2 tunnels are created, right? For each network pair, if you remember, then there is another important term here, proxy IDs, right? So we configure, we define proxy IDs, means if number of subnets are network increase, then there would be increase in number of phase 2 tunnels. Phase 1 tunnel is still same, only one. So whether policy based VPN, route based VPN, IPSec phase 1 tunnel only one. But what about the phase 2 tunnels? Phase 2 tunnels means like depends on number of networks or subnets in policy based VPN. So that's another reason why we do not prefer to go with policy based VPN. So policy based VPN is the legacy way, right? Nowadays we prefer route based VPN. So route based VPN is the latest way, and in route based VPN whether traffic will be sent unencrypted or encrypted, means tunnel or not tunnel, is determined after performing routing table lookup, right? So we create either static route or we do dynamic routing. So firewalls or VPN gateways look at the routing table, determine like whether packet need to be encrypted, put inside tunnel or not. Whereas in policy based VPN, we create policy. If this is the source and destination service, then traffic has to be encrypted or not encrypted, right? So that's the way how encryption is done in both policy and route based VPN. But the important point to understand here is in route based VPN we do routing, we do dynamic routing or maybe static routing, and most important and super important point is in route based VPN number of phase 2 tunnels would remain only one pair, no matter how many networks, how many subnets we want to protect with IPSec, right? Whereas in policy based VPN, number of phase 2 tunnels would get increased with number of networks or number of subnets, right? So in case if we are forced to use policy based VPN, then there are different ways to minimize number of phase 2 tunnels. No need to get into those details, but one of the way is maybe doing or aggregating different networks to a supernet or supernetting kind of thing. Another method could be like NAT. So either with the help of NAT or supernet, we could minimize number of phase 2 tunnels in policy based VPN. But in route based VPN, you don't have to do anything, right? Because with single pair of tunnels, like multiple networks or subnets can be protected. So which VPN configuration we should prefer? Route based VPN, of course, undoubtedly. Okay, so IPSec builds the tunnel for us, but it doesn't authenticate or encrypt user data. We use two other protocols for this, and one is like AH. AH is not used in IPSec VPN authentication header, and it uses protocol number 51 and ESP protocol number 50, and they both work on top of IP, right? So ESP and AH. So basically just above the network layer, in fact, AH and ESP, and AH ESP negotiated during phase 2, because for the user traffic, even proxy IDs in case of policy based VPN negotiated during phase 2 negotiation, right? So proxy IDs, AH or ESP negotiation done during phase 2, not during phase 1, you must remember. Alright, so I hope you understand the basics of site-to-site VPN, IPSec site-to-site VPN. So a quick recap what we have learned in this section, because in next section we will see how to configure IPSec site-to-site VPN, right? So in nutshell, IPSec site-to-site VPN is used to provide secure connectivity between two or more sites or locations using internet as the transport, right? So internet is public network, not a secure transport. So that's why in IPSec VPN, or whenever we use the term IPSec, is a framework, Internet Engineering Task Force framework, and it's not only about the encryption, right? Because encryption alone cannot provide data security. So in IPSec, as we discussed, encryption is done, data integrity, anti-replay, and data origin authentication, right? So and with IPSec site-to-site VPN, private networks are extended. We don't have to do NAT or anything, because original packet is encapsulated. Extra headers are added to the original packet, and extra header and outermost IP header means source and destination IP, that would be that of the gateway IPs, public IPs most probably, right? And even in case if your gateway is behind a NAT device, behind a router or any other device, then for that we can enable here nat-t, NAT traversal, so to take care of, right? So even in case if gateway doesn't have public IP address assigned, gateway is behind a NAT device, no problem, like at all, no problem whatsoever, right? So that's like the way like how it works. And another point we discussed in this section was like phase 1 and phase 2 tunnels. So phase 1 tunnel, phase 1 tunnel. So phase 1 tunnel is for the management or control plane, and phase 2 tunnel for the data plane tunnel, right? And phase 2 tunnel is basically unidirectional. Unidirectional means a pair of phase 2 tunnels are created, and phase 1 is bidirectional, only single pair, but phase 2 tunnel is data plane tunnel. Data plane tunnel, one inbound and the outbound. And then we also discuss about policy based VPN and route based VPN. So in route based VPN, only a pair of phase 2 tunnels are created irrespective of number of networks or subnets, whereas in policy based VPN, phase 2 tunnels can be more than a pair, in fact, right? Depends like how many networks or subnets we want to protect with. In FortiGate firewall, we can configure in both way, either like policy or maybe route based VPN. We do have option like to configure policy based VPN also, but generally we prefer route based VPN, and you understand the reason. And how like both tunnels are like negotiated, security parameters are negotiated, tunnels are built. So for that there is another protocol, and that is IKE protocol, Internet Key Exchange protocol, right? So IKE is used for security association, for symmetric key negotiation and computation. Basically symmetric keys are not negotiated, some key materials are negotiated between both the parties, and keys are computed independently by both parties, both VPN gateways. So basically final symmetric key is never exchanged between both VPN gateways, because that may cause a security risk, you understand that. So some key materials are exchanged basically, and they independently perform computation, and end result would be symmetric key, right? Symmetric key wherein same key is used for data encryption and decryption. For bulk data transfer, always symmetric encryption is done. Asymmetric wherein there is combination of private public key, one half of the key is used for encryption, another half for the decryption purpose. But asymmetric encryption is never used in bulk data transfer, right? Wherein in VPN, of course, there is the case of bulk data transfer. So because asymmetric encryption is very slow, in fact, as compared with symmetric encryption, so in VPN symmetric encryption is used. So I hope you understand like the theory part of IPSec VPN, and really it was nothing to do with FortiGate. It's just a high level overview of like IPSec VPN and VPN theory. In next section we will see like how we can configure IPSec side to side VPN in FortiGate firewall.